Welcome back, everyone, to my spring break episode of calculator programming. As you can see, I've been messing around, just trying to look at something that would, look good kind of on the background for a chess game. I tried brackets. I want something that's not too noisy. Yeah, so something like that might look okay. It's not too much detail, but it's also kind of explicit where the black squares are. There are no just black full, block characters. And by the way, I do want to do this with characters. The reason is because if I was going to do it with pictures, I would have to write some kind of part of the code to go and grab a piece from the picture. And I'm not very used to working with pictures on the TI-84. And it just would probably take a little bit longer to process all that. Graphics don't usually work very well. That's why I usually like to just stick with characters when it comes to any kind of programming with the TIs. So let's go ahead and get started and create a new chess. And so we're not necessarily going to make the computer play against us or anything. What we're going to do is try to make like a two-player where you kind of make your move and then you hand it off to the other player for them to kind of make their move. So let's go ahead and, we'll just start off trying to make everything visual. So let's go ahead and just do a for loop. So we'll use, I don't know, x and y. So for x is, let's say 0 to 7, because we want to, we'll add 1 to the coordinate to just make the background here. And then we'll just make y go from 1 to 8. And then we'll output y, x, and then brackets. And here we go. Chess is, dang, it's not numbered. Let's see here. I can delete CD. Let's delete that. That way we can access our program faster. Let's go down to programs and delete CD. There we go. Now all I have to do is type in 0 and we'll get chess. There we go. Okay. Okay. So let's add 1 to x and multiply it by 2. Okay, now that's all of them. Let's go ahead and put an if statement. If y, let's see, how did I do this last time? Y times x, y plus x divided by 2, the fractional part of that. If the fractional part of y plus x divided by 2. Yeah, that should work. We need to clear the screen. There we go. Okay, so I'm going to make sure that I do this correctly, so I'm going to find a board and make sure that I'm recalling how to do chess. By the way, I did program chess recently in Java, so that was fun, but I kind of used my code from like 7 years ago because I did it a long time ago. But then, since I'm in school now, that was one of the projects, but it was also a class that I dropped because I didn't really have the time to do that class anyway. and go ahead and just relax. I know some people like to write their code when they're watching these videos, and some people like to copy it and try to take notes and things. But don't really worry about that. Just relax and, you know, enjoy just watching me do what I do, and because it's not going to be, you know, perfect. You're not going to learn too much theory and stuff. I just kind of, this is more of just an introduction to programming for people, you know, who are still, I guess, just trying to get used to it in general. Okay, so alright, so we do want white in the upper left, so we'll have to swap our we'll say if not. Where's not? There is not. Okay, there we go. That's more like it. Okay, and the queen is in the 4th position from the top, and it's black. So let's go ahead and put in all our pieces. Okay, so I'm going to start, hold on a second, I'm running out of batteries on my camera. I'm going to go get, I believe it, oh, what is it, batteries? Or tape? I think I'm running out of tape in my camera. Okay, so welcome back. So I looked up the board, and it looks like the general rule is ladies first. So the queen comes on the left and the king comes on the right in both cases. So we're going to go ahead and just output on the first line, and we're just going to kind of hard code all our pieces to the screen so that we can see, you know, all the starting states and everything like that. And we'll just go from there because, yeah, I like to be visual. So on the very left we have the rook, so the black rook, we're going to put BR for that. Okay, and then we're going to put black knight, and we're going to put our black bishop, and then we're going to put our black queen, our black king. Uh-oh, now we got a king and a knight, so we'll have to figure out what to do for that. Put things back. So we got our black bishop, black knight, and then black rook. So the K seems like it can stand for both, and it also looks very, looks pretty pretty full, because you got all these B's and R's and K's and Q's, and it's not very visually stimulating, except it's maybe a little too much visually stimulating, I'm guessing. So not sure what we're gonna do about that, but anyway, we also got our black pawns, so we'll just do black pawns like that, and I guess that's gonna be what it looks like. I'm not sure. And again, I've never really done this, made chess on a calculator before. It might actually be a better idea to do it with graphics. Let's see, white bishop, white knight, white rook, and then white pawns. Okay, let's see what that looks like. That is the starting board. Kinda looks crazy. Not sure what I should really do about that. I mean, we could probably make it work, but it's just gonna look silly. So I might be able to change like the W's and the B's with like a line or something, like a minus sign, we'll say, would be like black or something. Like you have the negative team and then like the positive team, and it's really annoying that it keeps saying answer. I don't want the answer, no. So yeah, plus or minus, we could probably do those as teams, because it might be a little more intuitive. So not sure what to think about that. Black could be like the plus team or something. And the white could be the minus team. We could try that. Who knows, you know. I mean, right now we're just looking for functionality. We could make it pretty, but like I said, images, you can copy and paste sections of the image onto the graphing screen, which I could consider doing, or I could just kind of stick with this for the time being. And I don't want this project to take too long, because I kind of told whoever the commenter is, I kind of told him, you know, sure, I'll try to do this during spring break, but you know, who knows how deep I'll actually really go into it. So I guess we could do the plus and minus team. That works. The minus team would go first, but I guess that makes sense because they're left on the number line, so why not? So I guess it works out that the minus team is white. So let's get started with some logic here. Let's make an 8x8 matrix, how about? So let's go ahead and there should be a delete var. You know, I don't know where it is, but I know it's in the catalog here. So we'll just say delete var matrix A, and then we'll say 8 store as the dimensions of matrix A. And then we'll have a different value for each. We'll say each unit has their own value. So we could do like a decimal for the 6 types of pieces, and maybe the first number would be like a 1 or 0 to say like what team it's on or something. We could just do something as simple as that. Doesn't really matter, not a big deal. So we might as well do that. So yeah, I suppose we could make pawns 0, and then we could make, and we'll just go from left to right as we read the line. So we'll look at the white pieces in order. So pawn would be 0. A knight, a rook would be 1, knight would be 2, bishop would be 3, queen would be 4, and king would be 5. And then, so that's 6 different pieces. And then we could make the black team, we'll start at 1.0. And then 1.1 would be the rook, 1.2 would be the knight. So let's do that. Let's go ahead and do that. So yeah, might as well. Although it'll be hard to print out. No, we can look at the matrix for debugging. We can change this, I guess, if it doesn't work. We can go through our code and probably change it. So let's go ahead and number them so that we can easily identify them without having to do strings and things like that. So let's go ahead and edit this. Let's go ahead and just store it into the matrix, actually. That seems to be a good idea. Yeah, that seems like it'll work, maybe. Or let's do a couple loops. Actually, that seems like it'll work. So let's go for x is 1 to 8. And then we're going to do for y, and then we're going to go directly to the second line, and we're going to go to 7th line, and we're going to count by 5. Or, you know what, we'll go no, we'll just do 2 lines. So let's see, 1.0 or 0.0, we'll just have 0. No, you know what? Scratch what I said earlier. We need a value to be the background, and a pawn wouldn't be good being a 0.0, because if one of our team's a 0, we should change that. Maybe pawns should be a 0.1, or the white team should be a 1 and the black team should be a 2. Who knows? Let's make our pawns a 0.1. So 0.1 store as matrix A. We want our y to be 7, and our x to be whatever x is. And then we're going to do 1.1 store as matrix A 2, x. Okay? So we're going to go ahead and run this chess. And then we're going to look at the matrix to make sure it got written correctly, and looks like it did. Okay. So let's go ahead and put in our other pieces. So we're going to say let's do x is 1 to 3. Okay. And this is where we're going to put in our knight, our rook, and our bishops for everything. So so we'll take x over 10. So x divided by 10 is going to be our unit piece type. okay? And then we're going to take 1 plus p, and we're going to store that into matrix A 1x. Okay. And then we're also going to take that same value and we're going to store it into 1, and then we're going to start from the right side. So x is going to start at 1. So what's 9 minus 1 would be 8. So we would do 9 minus x. And now we want to take 0 plus p, so we're just going to do p. Oop. And this is going to be for the white team. So these two lines are for the black team, and these two lines are for the white team. And we're going to store those as 8, and then the same values, x and 9 minus x. Okay, let's see if this works. Okay, let's edit it. Or not, oops, not edit it. We're gonna check the matrix. Okay, 1.1, 1.2, 1.3, 3, 2, 1. Perfect. 1, 2, 3, 3, 2, 1. Okay, so we laid out the knight, the bishop, everything like that properly. Although these should be one more than what they are currently, because remember we're making the pawns 1, not zeros. So we're going to have to do 1 plus p's down here. So x divided by 10 plus, or x plus 1 divided by 10. And there we go. Now we have individually identifiable pieces all the way up to the king and the queen. So we still have to put those in, but those will be pretty easy. And we'll just put 4 lines of code for that. So let's see, we have up through 0.4, and then 0.5 and 0.6. 0.5, sorry, 0.6, 1.5, 1.6. So these are our kings and queens. This will be the white piece. So these are all, obviously these are all matrix A because that's the same chessboard. Okay, and the white piece is at the bottom, so 8s, and the black piece are at the top, so 1. And we got our 2 middles, so 7 and 8. 7 and 8. I believe that should be correct. So let's go ahead and do that. Oop. If it just printed out to the screen, that should be okay. Something. Well, our 2, 3s, and 4s work. And I must have done something wrong already, because these values are not getting written to, and I'm not sure why. So let's do a stop here and see if we reach the statement. Oh. Oh, it didn't print. Oh, it did print high. So something's wrong here. It's not getting printed. .6. Yep, something's definitely not working already. So it's reaching the statement, but 0.5 is actually not getting stored into matrix A 8, 7. That's not happening. I don't know why it's not happening. Maybe 0.5? I have no idea why it's not working. 1.5 store into matrix A, y value 1, x value 7. No, that's not even correct. My mistake. It should be 4 and 5. Yes, that was my mistake. So matrix A, there we go. So we got the 5 and 6 in the middle. So the queen is a 5 and the king is 6. And we got all our pawns. So now all the pieces are in a data structure. And yep, that seems to work. So let's move on to the next part of this game, which is we are going to, for any piece, we are going to calculate the pieces, essentially the pieces like possible moves, like where it can be moved to. So it'll take a little bit of programming just to get the moving logic down, because we're gonna have to do, you know, lateral and diagonal and things like that. But it should be okay. Shouldn't be too bad. The pawns, I think once we move them, we'll have them set to a different value. So we'll set the pawns, once they move once, we'll set them to a value of 0.7 instead of 0.1. So 0.1 will tell us whether the pawn has moved yet, and 0.7 will be the value if the pawn has already moved, so it can no longer move 2 pieces in front of itself. Okay, so let's go ahead and, you know what, we might as well program the pawns first. That should work. So yeah, that should work. So the first thing that I want to do is I want to program the ability for us to control our cursor. So I'm going to do a loop. So I'm going to say while 1, and I'm going to put a cursor somewhere on the screen, and let's see here. Nope. My bad. Let's go ahead and set 4s to be the x and y value, to be the start of the cursor, and then let's go ahead and put some dots like that. So we're going to output y, x, and then this ellipse thing right here, the colon. And instead of using y and x in favor of our output screen, let's use them in favor of the matrix. So that means we're going to have to multiply, since the x is going to be valued, the x is going to be valued at from 1 to 8 rather than 0 to 7. So we're gonna have to multiply it by 2 and subtract 1. So, but that's fine, it'll work. So there we go. We have that output statement. And then we're gonna have our get key. Oh. Let's see here. Oh, where's my end? Get key store as we'll just say A. If A equals, and then remember how we do the controlling. So here's my controls here. This is 24, this is 25, this is 26, this is 34. So if A equals 24, we're going to subtract 1 from X. If A equals 26, we're going to add 1 to X. If A equals 25, we're going to subtract 1 from Y. And if A equals 34, we're going to add 1 to Y. And we'll see if that works right there. And it looks like it does. So I can move around. And this is how I'm going to select things. So as soon as I select something, I'm going to see all the moves where it'll be possible to go. So let's just go ahead and we'll add wrapping. So we'll check first to make sure that our wrapping works. So if A equals, or not A, if X equals 9, then we'll store 1 into X. If X equals 0, then we'll store 8 into X. If Y equals 9, we'll store 1 into Y. And if Y equals 0, we'll store 8 into Y. Okay, so let's make sure that that works. So I'm going to go left, boom, I can wrap the screen. I'm going to go down, boom, I can wrap the screen. I'm going to go right, boom, and up, boom. So it works. So let's go ahead and get back here. And we do want to keep track of our old X and Y. So what we're going to do is we're going to save S and T. Okay. And this is where it gets tricky because we're going to have to do a check. We're going to have to output whatever's in the matrix. We're going to have to output its correct string. So that's going to be tricky. What we could do is we could make like a subroutine function. I don't know if I really want to do that. But it might be easier that way. Let's go ahead and let's see here. We'll do it. We'll try that. So for B is -1 to 0. We say if B, then we go to, and this is you might be if you're probably a decent programmer, you might be telling me, you know, don't use gotos. You know, everything can be done, you know, without using gotos. You can recursively, you know. The problem in the context with TI-84 calculating and the TI basic, You can do recursion, but you have to make a new function in order to do it, a new program. And the thing is, I don't want to actually create a new program every time I want to call something that's like a function. And the only way to really do a function is to actually kind of like program it yourself. So I do need to kind of use the goto here as like an assembly instruction type thing. So I say if b go to 0. And what that's going to do is it's going to continue. The first time it goes through this loop, it's going to go jump down and it's going to do this subroutine that I create for it. And that's exactly, that's exactly how I want it to work. I want it to work kind of like our subroutine. So I'm going to call this label 0. And then I'm going to put an end. And what that's going to do is that's going to pretend, it's going to think that that's the for loop's end. Which, according to how TI basic works, that's what that end is actually going to, that's what it actually is. So it doesn't get compiled as something else's end. It reaches it because it does everything here in procedural order. So it's very close to like assembly. Everything is computational order here. So I'm going to label this label 0. And this, I'm going to call it whenever I need to print out a piece. Okay? So I'm going to set some specific variables to be to kind of tell me what I want to be printed at a specific location. So these variables, I think I'm just going to use n and o. So I'll use n and o. I need to set the value of the matrix spot that I'm trying to print. I need to set that as some variable. We'll just use p, I suppose. So here we're just going to be checking, if p we'll just say like if p equals, who knows, point, if, let's see here, if fractional part of p hold on a second. Let's give me a second here. Okay, here we go. If p minus its fractional part, that's going to give us the team here. So yeah, if so, we're going to say if p equals 0, we're just going to do an end, and we're going to store nothing. Oh, okay. We're going to okay. Okay, this is tricky because I can't say return, I have to say end, so I can't put the end inside of an if-then structure. I have to put it inside an if structure. So this is kind of tricky. Okay, so I want it to return if p is 0. This is okay. I'll just do 2 checks. So if P is 0, that means there's no piece there, right? So what I want it to do at that place, at that time, is I want it to actually give me what the background should look like. So I have to check if the x, if 2x, if matrix A of y comma 2x minus 1 no, I don't need to check if the matrix, oh great. Darn. Okay, no, I don't need to check what's there in the matrix. What I'm doing, because I already know, because I'm just printing, so this subroutine right now, I got it set up to only print. It doesn't do anything with the matrix. It just prints what I tell it to print, where I tell it to print. So if y plus x divided by 2 okay, then and then we're going to put an else. Okay, so what this is doing is I'm entering the subroutine with label 0. And if p equals 0, that means the subroutine, I'm telling the subroutine, like, hey, print this piece, but the piece doesn't exist. So I'm just printing that means I'm going to have to print the background. So then inside of that, here I'm going to print the background. And I have 2 then statements that I have to end. And then I have to get an end without a then statement because I have to end the subroutine with an end. Which is kind of confusing, but that's the way it works. Subroutine that I'm doing is kind of hacked version. So it can't be inside of anything that uses an end. And I don't use the word return for it because return is used for an actual, like, I'm going to make another program type subroutine. So it's a more formal way to do the subroutines in TI Basic. So if the f part of y plus x divided by 2, I believe okay, so if it's not that, then I do the brackets. So if it is that, then I do the spaces. So I'm going to store it into string 1. So I'm going to do double space, store into string. Ooh, where's my strings? Vars string 1. Yep. Okay, and then I got my brackets here. Store into string 1. Yep. Okay. So that'll give me string 1 will be my whatever my output thing is there. Okay. So this is a subroutine that just kind of like it exchanges a matrix value for a string. That's all it does. So I can use it however I want as long as I use it like that. So if p minus p part okay, so what that's going to tell me is okay, so if f part of p, that's going to tell me if the value it's going to tell me the team the value's on. So if this is true, this is going to be black. Okay, so the then is going to tell me it's black. And then else, it's going to be white. End. Okay, so black, white, I'll just put B and W just to like remember. Black and white go there. Okay, and then P minus F part. Oops, that's the one where that's actually black and white. Made a mistake there. Oop. Okay, so this is black and white. This part right here is the fractional part. So I'm going to store that into P because I no longer need it anymore. Okay. So I'm just going to store that into P. So I'm going to say if P and I'll multiply it by 10. Okay, so that way I know if P equals 10 or 1 or P equals 7, then I know that it's going to be what's it called? It's going to be a pawn, and so on and so forth. So I multiplied the decimal by 10, so I can check if it's 1 or 7, it's a pawn. If it's 2, it's a rook. If it's 3, it's a, and so on. So if P equals 2, then I'm going to add rook, okay, to string 1, and P equals, so this just takes a minute just to convert, I mean, strings to like data values is kind of annoying, but I mean, it needs to be done, so I mean, I don't really have a choice. Rook, excuse me, what comes after a rook? Okay, a knight. I might put N for king, or I might actually no. I would put N for knight. I'm gonna put N for knight because yeah, I'm gonna put N for knight because we need K for king, and the K sound goes more with the king than it does with the knight, so we'll just say it goes by sound rather than spelling. So if P equals 4, and what's nice about the way I split it up right here is once we do this, we don't have to do it anymore. We just add whatever to the string and we're done. So if P equals 5, well, let's see, 4 is knight. No, 3 is knight, 4 is bishop, 5 is it queen? We're already on queen? Yes, we are, because there's only 6 pieces. And let's see here, P equals 6. We have string, we have string 1 plus king. Oh, store is string 1. There we go. Let's go make sure that we get this black and white thing. Oh yeah, and by the way, we just need to do we literally just need to do B store is string 1 and W store is string 1. Who knows? This might already work. Okay, so I moved down. Okay, so why did I think that would do anything if I'm not using it at all? Okay, so we call the subroutine. So now we're getting string 1. and I'm gonna output in our old coordinates TS, or actually 2S minus 1, and then I'm gonna put string 1. And that's as simple as that. That's what I'm gonna do. So when I output the new one, I'm going to save the values. So X and Y, because I already printed out the old one. And now, ooh, oh, that didn't work. that didn't work. Okay, it's outputting the background correctly, which is good. That's good. Oh, the plus and the black and the white I did wrong, my bad. I said this is all I need to do, as if it was like a magical, but all I need to do is put plus and minus, not B and W, because we're using plus and minus. So, what did I do wrong here? Where am I? Oh, I need to store it as P. I forgot to do that. Oops. Okay, so I'm going to store S and T. I'm going to store as N and 0 and O. Wait. Oops, no, stay here. Wait. Hold on, something's not right. How did it do the background correctly if... Oh, shoot. No, not Y and X. Nope. That's supposed to be O and N. Yep. So, yeah. Yeah, because those are supposed to be the old values. So whenever I move, it's supposed to erase the old values with whatever's supposed to go there. And then before I call this, I need to set P. So I need to set, so matrix A, ON stores P. Okay, there we go. Now, okay, it's inverted. Okay, BP, Black King. This is already taking forever just to print out. This is White Bishop. Okay. Okay. It seems to kind of be working, except the background, I don't understand. Why is the background inverted? That's not right. That's not right at all. Although the pieces are in the correct spot. That's a funny thing. But the background should not be inverted. Yeah, if the fractional part of O plus N divided by 2, then blank. What? Oh, and I also messed up here, because these should be minus P. Oops. This should be P. Okay. And then, yes, something silly is going on here. If not the fractional part of x plus y over 2, then I output brackets. Oh, I know why. It's because my x is 0 to 7 there. That's why. Okay, that's fine. So we'll just have to swap these then. So this will be spaces, this will be brackets, and then down here we're gonna put plus and then minus, and this should work. Okay, so I'm gonna move around, and hopefully the background that gets erased behind me, the correct item gets displayed. So I'm gonna move around. The queen, okay, looks good, looks good, looks good. Looks like it's all working. If I jump over, looks like I can wrap the screen and it doesn't mess up. Okay, so good. So every item has a correct value, and it's actually printing the values according to what's in the matrix. So this actually works out like just perfect. Like, this is actually really, really good. This is really nice. So yeah, let's go ahead and I guess we're gonna get to the more complicated stuff now. So as soon as we move, so what we should do is actually we should wait. So we're gonna do get key stores A, and then we're gonna wait here, and we're gonna say repeat A, and then we're gonna do get key stores A again. And that way, okay, so that way we're not doing anything. That way it's, right now it's not doing anything but waiting there in the loop. So when I press down, okay, it moves, it starts exactly from that loop. Okay, it's not getting stuck in there. And the reason why I really need to do that now is because I'm gonna add a lot more to this loop. It's gonna be more complex. So we might even make more subroutines to check up, down, left, and right, so this will get kind of complicated. And I think I'm going to take a little break really quick, because this is pretty long of an episode. So I'm going to take a little bit of a break, just to just give my brain a little bit of a rest, and then we'll get going again. Okay, we're back. That was a very long break. Took a nap and watched TV, and yep, it's like nighttime now. But I gotta finish this video, so I'm gonna attempt to do so. I'm gonna do my best, and we'll just start kind of where we left off, and that's where we actually select different pieces and see where we're gonna move them. So we're gonna use the blue key here and to select. So let's see, that's 21, I believe. Oops. So if A equals 21, then that means we pushed the blue piece, and that means we want to select whatever piece is there. So we could put that all in a loop, I suppose, and then exit it when... I suppose we could just exit it when we are done. So we will have to rewrite the whole recognition. Or what we could do is, instead of making a loop, we could just change the state of the loop. So the loop can have two states. It can just have a regular game, like you can select a piece, and then it can have the state of you have selected a piece, and we're saying where to move it. And we're going to have states anyway, probably without a loop, because we're going to be switching between the white player and the black player. So here we are. We select a piece, and we have to check to see what state we're actually already in, just to verify that we're going to switch. Let's do the switch states. Okay, so let's see here. We're going to have a state that verifies which player we are, and I think what we'll do, in fact, this will be the perfect way to do it, I think. We're going to have a state that can range from 0.00 to 1.7. So we're going to use a number to tell us what state we're in, and if the number ends in a 0, that means we have not selected a piece. If it does end with a piece value, then our state will be that we have selected a piece. So, and if it's 0, then we're the white, and if it's 1, we're the black. Okay, so let's go ahead and put 0 into our state, and I don't know what we should use to keep track of what state we're in. We could use B. We can't use S for state because it's already being used. So let's go ahead and use B. So B. No, we can't use B. We can't use B. What about Q? Is that crazy? Can I use Q? Let's use Q for our state. Okay. And then for our for this, we can actually decide, we're going to show whose team we're on, or who's the player here. Okay? So if Q let's see here, because I don't know if I want to change this later. Let's separate it right now based off. Yeah, let's just separate it by team right now and forget about whether we selected a piece for displaying the cursor. So if Q is greater than or equal to 1, that means we display the black piece, or the black team cursor. And let's put the plus sign on the right side. Okay? And then and then we'll just use the minus sign for the white. Oop, this sign. So let's do a colon and then a minus. And then I don't really have to end those, but I just will to make it easier to see. So yeah. So depending on which player we are. So we're going to start off as player 0, so we're going to start off as the white player. Which would be negative. So when we run the game, our cursor, what? Oh, this is an example of me. I'm apparently tired right now. Okay, so here's our minus cursor, and then if I make a move, then it should switch to the plus cursor to show that we're the black team. So right now I'm not worried about how pretty it looks. I know I can only do my best when I am so hard-headed that it will only use characters, but I do want to make it obvious. I want to make the information come across. So I want to be able to, I want the players to be able to tell whose turn it is and where the pieces are and everything like that. So as long as it's informative and it's not ambiguous, I'll be satisfied. So if A equals 21, then that means that we've pressed the blue button and we want to check to see if the piece we're currently hovering over with our cursor is an actual piece that we can move. So we're going to check. We're going to check if matrix A, or actually, you know what? So, okay, so, yeah, this will work. So we can just store the value, actually. We can store, we need to store the coordinates, and we need to store the piece type. And if the piece type does not have a fractional part, or if the, right, then that means it's an actual piece. But first we want to weed out, if we select a piece that's an enemy piece, we don't want to move it. And if we were trying to select like a background piece, we don't really need to do anything there either. So let's weed those pieces out. So let's just go ahead and store our selection. So we're going to store this as P, and I think I can use P, because P here, P is used for the subroutine, so it's not a global type variable. So we can use P independently here inside of this if statement, and it won't have anything to do with the other P. They'll both get used on their own time. So we're going to store the value into P, and we're going to do an if. Okay. So here we're going to check just to make sure. So if the fractional part of P, if we just say if the fractional part, that means it'll be true if there is a fractional part. It'll return 0 if there is no fractional part. So there we weed out that. But we can also say and. If the fractional part of P, and, what should we put for the and? And we want to make sure that it matches the team. So Q equals the integer part of, so we'll just say the integer part. No, that's the imaginary part. This is the integer part. So fractional part of P, and Q equals the integer part. Right. I think. And that means our state, this is perfect, because if, let's say we have a piece selected, the fractional part will actually be the fractional part of Q will actually be non-zero. So that means it cannot equal the integer part of P. So this works. Okay, so this if statement, this will only enter this if statement if we are not in a selecting piece state already, and we have selected a piece. Okay, and that's this combined with this, and this also makes sure that we're selecting a piece of our own team. Okay, because I'm taking the integer. So that should work for all, weeding out all those other branches there. So that means when we enter this state, this is exactly what we want. We want to go, we just selected a piece, a valid piece to select, and we want to check to see if we're able to, like, where we're able to move with it and everything. So let's go ahead and let's go ahead and get some valid moves here. So I'm going to say if okay. What I could do is work with matrix A and give a negative value for all the places that we could move, but the problem with that is we wouldn't be able to tell the difference between a 0 background piece and a non-zero background piece. So what we could do is we could add like 2 to every value, and then we could print out the pieces accordingly. So if there's 2s, we could know that the background is being tracked. So this is kind of tricky. Yeah, this is definitely kind of tricky. If we'll just go ahead and program the pawns. We'll see if we can do the pawn pieces. One step at a time. One step at a time. So if our current position, you know what, let me save y and x first of all. Okay, so y, so those are going to stand for the piece that's currently selected. And then we already have p. Oh. You know what? We might want to keep p around, because who knows if we need to do some checking with p. Let's just ignore that for a second. Okay, so we're going to store y and x into j and I. And those are going to be the coordinates of the piece that we're checking around to see where it can move to. We're going to do an if statement. So if p if the fractional part of p equals 0.1 or the fractional part of p equals 0.7, okay, we're going to do a then, we're going to do an end. So if the fractional part of p is 0.1 or 0.7, that means we selected a pawn, and we validly selected a pawn at the correct state. So it's guaranteed that in this then end branch right here, it's guaranteed that we're in the state of we have just selected a pawn of our team correctly. So then we need to check. Okay, so we need to see how many moves it has available. You know what we could do? And this is kind of crazy, but we could actually store the number of moves, like either in the cursor or we could show it either in the cursor or we could show it like on the piece. So we could show the piece has, we could show like the piece has, instead of showing the team, we would keep the cursor showing the team, but the piece would, instead of showing the team, it would show a number showing how many moves it could make. How's that? That sounds like it would work really well, because the cursor already shows the team as it is, so we might as well keep that showing the team. And then the piece, I mean, it's associated, the piece is what we're trying to move, so we might as well associate the number of moves it can have with the number, and we'll put the number on the left where the plus or minus goes, because we already know the team that we're on anyway, because we're selecting the piece. But we might forget what the piece is, so we'll have that be the thing that we're not covering up. We'll have that on the right. The only issue is if there's more than, there might be more than 9 moves, but that'll be okay, I think, because we can just put the number in both spaces. So if there's like 15 moves, we can just like put 15 or something. Or you could even put a star if it goes over 9. We have options here. So this will work. Here we have to check if the team, so if P is greater than or equal to 1, then it's okay. If P is greater than or equal to 1, that means it's the black team, so we're trying to move down. Otherwise, it's the white team, so we're trying to move up. So let's see, if P is greater than or equal to 1, it's the black team. So let's let's have a piece counter. Let's have a piece counter. So here, okay, so here, we're gonna initialize C here, actually. So C is gonna be 0 to begin with, and we're gonna count all the pieces, how many moves we have. Yeah, so 0 is going to be stored into C, and then we're going to add 1 to C for every valid move that we can make. So if P is greater than 1, that means it's the black team, otherwise it's the white team. So we're going to do the white team right now because we have to check. Oh, this is tricky. Okay, so this is getting really, this is going to be a lot of code. It's a lot of like checking code and stuff. So we need to check the P. Okay, we're going to check the piece in front of us to see if we can move there. So we just have to make sure it's just blank, because that's the easiest one. So so if J minus 1, because I think the top of the screen is 0 and the bottom is 8. So we're trying to move up 1. If J minus 1 is greater than or equal to 1, okay, that means if there's a space above us, okay, then we check that space. if matrix A what? Oh, okay. I'm looking at my calculator from an angle. Okay. If the fractional part of that if the fractional part of that is 0, so we're just going to put if not the fractional part of that. Okay. Then, and we're going to add 1 to C. Okay. Because that means we're going to be able to move there because there's nothing there. So the space above us exists, and there's no piece there. Okay. Okay. So now let's see if we can mark the piece, and we'll display our number where we are. So let's go ahead and I'm not sure how to do this, but maybe, oh, you know what? No, count is stored. So we don't need to store that into the piece or anything. So we can just show it. Yeah, that'll work, I think. Count is 1. Thinking here. How do we know how to display? Oh. Okay, I've got an idea. I think. No, that won't work. I guess we could display the count every time we move if we are actually, we can just overlay the output with our count, I think. Can't we? I'm trying to think here. If I add 2 to the position that we're trying to go to, then that means I'll have to check. That means I can identify where I'm going to. You know what? I'll add 2 to it. So, yeah. Plus 2, store as matrix A, I, j minus 1. Yeah, that'll work. Okay, so our count is updated, our destination is updated. Yeah, that should work. But we need a way to switch back. I'm not sure how we could do that. We could add the green button as like a kind of like a undo type thing, like cancel. But I also want the cancel to be like the normal way to cancel, just to select the piece again, or to select like an invalid move or something, because that would be easier. But I don't want to put in the logic for that yet, so we'll just put everything we need here, and then we'll copy it over to a branch in here when we end up doing that. So I can't think. If a equals 31, that means we want to just cancel. So our q minus the fractional part of q, or int q, stores q. And I think that's all we need to do, because I think, oops, yes, I think, not totally sure. So I'll move around, I'll select a piece. I should be able to see all the destinations. Oh, no, okay, so I need to cancel this. So, okay, so I'm going to store in list 1 and in list 2. I and j. So I'm going to store I into list 1 and j into list 2. And the reason why I'm going to do that is because I'm going to keep track of all the coordinates. Yes. Yes. Okay. That should work. So no, I am going to make this into, I'm going to put a little loop in here. So for B is 1 to C. And then I'm going to go through each of the, I'm going to take matrix A, and I'm going to take list 1's C, or list 2's C first. List 1C, or list 2C, list 1C, minus 2, and store that back into matrix A, list 2C, oops, comma list 1C. Okay, so what all this statement is doing is it's going through all, whoa, is that all I needed to do? Did I get that right? All this statement is doing is it's subtracting 2 from all the places that we marked by adding 2. Okay, that's all it is. So one last thing we need to, well, two last things we need to do is, one, we need to display, well, three last things. Okay, so we need to display right away. when we first draw it, and then we need to display it as the background, and we also need to display the count, and we need to add that into the loop. So here's the count. We get an increase. We need to show that we're gonna like jump somewhere, so we're gonna put a star at ij. So I'm gonna output at ji star, but we're gonna put it on the left because we always know that's the enemy. So, and we need to multiply this by 2, and I think that'll work. Do we need to subtract 1 from that? I think we need to subtract 1. Okay, so star means we're trying to jump somewhere. And then we need to put that in the loop down here. Okay, so if the fractional part okay, here we go. If p equals 0, then if the wait, hold on. This is the subroutine for printing, or for storing the string for where we're gonna print back. Shoot. If the fractional part of O plus n are our coordinates of what we're trying to, where we're erasing our cursor. What was I doing here? Oh, okay, yeah. That's if nothing's there. Okay. P equals 0 and okay. So if p minus fractional part of p, oh, and this is our problem. So this should be equals 1. Here we go. Okay, so we're going to put it in here. So if it equals 0, it's going to be negative. And if it exists, okay, is greater than or equal to 2. Then we're going to store a star. Okay. So now when we move the cursor, we should correctly erase. Okay, and now we need to put in the number. So C C is the number that we're looking for outputting. So if Q is in a state where we have a piece selected, then we want to output Q at those coordinates. Okay. So let's go ahead and do that. And we'll do it where will we do it? Actually, what we could do is we could build it into the background just like we have it set up already. So what we could do, okay, so let's see here. So when you, well, not 31. Okay, if a equals 21, then, so that's 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1, 0, and then the end. Oh man, there's so many loops here. Shoot. 5, 4, 3, 2. I can't keep track of my ends. There's so many. How do I know if I'm in the correct one? If a equals 21, then. So I start at 0, 1. And then if I hit an end, it's 0 after that end. Okay, so it's 0, and then this becomes a 1. Then when I hit an end, it becomes a 0. So that's how I'll know that it's the end that goes with this. So this turns it into a 1, 2, 3, 4. Actually, wait. I need to make sure that's the actual if statement I want. It's not just if it's 21. Okay, it's not necessarily. So if there's a fractional part and Q equals int P, and we'll just to make sure that we're in the right state, we'll say and, because we could be selecting a piece that we'd be moving to when we already are in this state, and we don't want to enter this if we are moving to a piece, if we are trying to select, if somebody selects a piece that we're moving to, that I think that would still meet the conditions, because there would be a fractional part because it could be a piece that we're attacking. Q could be in the state Q, no, I don't think Q would be in the state, the piece that we're attacking. Because if the enemy piece, would be on a different, no, because we could be selecting our own piece. No, because we wouldn't, if we're selected, even if we were selecting our own piece, so we wouldn't have added 2 to it. We could only add 2 to enemy pieces. So this should be okay. let's see here. I was going to output, I want it to output the C at the end of the count when we know we have no more moves to add. No more moves that we can get to. We want to output the number there. So 1, 2, 2. Okay, it's inside the 2 is where we want to do it. 3, 4, 5, 6. Okay, so it's 6 in here. This makes it 5, makes it 4, makes it 3, makes it 2. So it's after this end is what I want. Okay. So I want in here, I want to take I and J, and I want to like mark them. I want to mark the piece that we're on with the count. If that makes any sense. But we're just going to negate it. So we're going to take negative matrix A, Ji, and we're going to store that into matrix A, Ji. Okay, so what I'm doing here is this is how I'm marking the piece that we selected. And that way it's easier to just print when we do it at the bottom there. And then I'm gonna mark, and I'm gonna output C. So Ji, and then I is gonna be, we're gonna put it on the left side, and we'll have to change this code later to account for the C being if it's more than like 10, for example, more than 9. Okay, and so that means we have to count for it being negative. Let's go back. What was I going to change up here? I was going to change something up there. I forgot what it was now. Yeah, but okay, but we do need to change down here. We need to change, we need to output it if it's negative. We need to display count. So if p equals 0, we do all this stuff with p equals 0. If let's see, if p is negative is less than 0, let's use a different variable for in here. Let's use b for the fractional part. Yeah, let's do that. Yeah, so we're going to take, if it's less than 0, then it's going to be the negation of Oh my goodness, I don't know what I'm doing. Hold on, let me think about this for a second. If it's greater than or equal to 2, then it's going to be that. Otherwise, it's going to be that. If p minus f part of p. Okay, actually, it'll do this because it'll be negative. Okay, it won't be positive. If p minus f part of p is greater than or equal to 2, it won't be if it's negative. Then we'll have the else here. Okay, so we can say if p is less than 0, then we're gonna put this we're gonna put count. Oh great. This is not good. Okay, forget that. Because I need to display C, which is some arbitrary value, and I want to just output that. I don't want to return it as a string, which is what I'm trying to do here. Oh, this is just wonderful, isn't it? If P if P equals 1 or P equals 7, okay, so this isn't even going to work here because this will be negative. Oh, wait. Oh, you know what? You know what? You know what? It doesn't even matter. You know what I'll do? This is what I'll do. I'll do absolute value of P stars P. And then I'll just forget about that. And wherever I call it up here, wherever I want to print out the piece, I'll have them check if it's 0. That's exactly what I'll do. If it's -1. So that'll be it'll be a special case. So here I do the loop, go to 0, end. Okay? And then I output the string here. Okay? So if I guess I'll have to make another variable here because because once I call this for loop, that'll be a subroutine. P won't be negative anymore, but I want it to be negative when it comes back. because I want to be able to tell if it's negative. Oh, but you know what? It won't even be a fractional. Oh. And I don't want to call the matrix twice. So I can just, I guess I can just store it in a temporary variable. Nope, not B. B's being used. Can't use C. I guess D is the new temporary variable. So if P stores D, so I'm just saving P's value because P's value gets changed in the subroutine, and I want to output this the C after I output the string. So I'm going to output C depending on if D is negative. So if D is less than 0, then I'm going to output J, comma 2, I minus 1, C. I think, and we'll see if this even works. Okay, nothing should be changing yet until I actually select a piece. Okay, so let's press the second button. Okay, so there's a 1. Okay, good. So it can move to one spot. Okay, now if I press, I press the green button. So let's see if I move there. Okay, it doesn't go there anymore. Let's press blue on here again. Okay, so it's 1. And I'll press the green. Okay, so it seems, so far it seems to be, I haven't caught anything that hasn't functioned yet. However, I forgot to put in one thing. I want that 1 to go away right away. So inside this, when we press the green key to cancel our move, we need to set, we need to negate. So negative, oops, wait a minute. Do we negate it? That's a good question. In fact, let's check out matrix A really quick. Let's see if there's 2 negative values in here. There's not. Huh. When do I negate it? What? Wait. Wait. Hold on. Am I forgetting something? If I come down here and I select it, now there's a 1. Okay, when I quit at that state. No. Oops. 1 and then quit. Okay, now look at matrix A. It should be negative, which it is. Then how, wait, how did it get set back to not negative? I thought I didn't do that. Did I negate it again or something? That doesn't make any sense. When did I negate it again? Did I? Uh-oh. Something's amiss here. This is where I negate it. Okay, I negate I and J, so that makes sense of how I could have re-negated it, because I and J were the coordinates of but that something's wrong, because it should not be able to get in this loop. At all. It should not be able to get in there. Maybe I counted the ends wrong or something, but or maybe either I'm wrong about how many ends I counted with those if statements, or I'm wrong about the conditionals blocking it when you're in the wrong state. Okay, so that should be a 1, and it should stay a 1. And if I press alpha right here, that should not have changed it. Okay, I pressed alpha. And when I go to, or not go to, when I look at the matrix, it shouldn't be positive, because if I press alpha, So okay, so we're gonna figure this out here. If it's the last thing I do, I'm gonna figure out why that's outputting by. I'm gonna output on the first line like a debug statement. Here. Oh no, you know what? What? So if this is then statement 1, then when I reach then statement, or end statement 1, it should be inside of it. 2, 3, 4, 5, 4, 3, oh, wait a minute. Wait a minute. I'm so bad at counting this if statements. It's really frustrating. I'm really bad at it. I'm really bad at being able to tell. Okay, so touching this then, I go from 0 to 1. So I'm going to count this as 1. This is 2. Okay, so it's in space 2. So it needs to be in space 2. Space 3, space 4, space 5, space 6, space 5 after this, space 4 after this, space 3, space 2, and this is where it is. So what? Hold on a second.